In our previous video, we talked about spin awareness and general spin recovery. The ACS, or Airman Certification Standards, gives us specific guidelines for what we need to know and demonstrate in order to pass a private pilot check ride. The ACS states that the objective is to determine that the private pilot applicant exhibits satisfactory knowledge, risk management, and skills associated with spins, flight situations where unintentional spins may occur, and procedures for recovery from unintentional spins. As a private pilot applicant, you will be required to demonstrate understanding of aerodynamics associated with spins in various airplane configurations, to include the relationship between angle of attack, airspeed, load factor, power setting, airplane weight and center of gravity, airplane attitude, and the effects of yaw, what causes a spin, and how to identify the different phases of a spin, as well as how to recover from a spin. You will also be required to demonstrate the ability to identify, assess, and mitigate risks, encompassing factors and situations that could lead to inadvertent spin and loss of control, range and limitations of stall warning indicators, such as airplane buffet and stall horn, improper spin recovery procedure, effect of environmental elements on airplane performance related to spins such as turbulence, microbursts, and high-density altitude, collision hazards to include aircraft, terrain obstacles and wires, distractions, improper task management, loss of situational awareness, or disorientation. The 4 phases of a spin are entry phase, the incipient phase, developed phase, and the recovery phase. The entry phase is where the spin begins with an uncoordinated stall, often caused by excessive yaw due to improper use of the rudder. Insufficient airspeed is another factor involved in causing spins. The aircraft's nose drops and one wing becomes more stalled than the other, initiating the spin. The incipient phase is the transition from a stall to a full spin, and it takes place from the time the airplane stalls and starts rotating until the spin has fully developed. The nose remains below the horizon and the airplane rotates around a vertical axis. The spin develops a constant rate of rotation and the flight controls become less effective. The developed phase begins when the aerodynamic forces are in balance. The spin stabilizes in this phase, with the aircraft maintaining a consistent rotation. The nose remains below the horizon and the aircraft descends in a spiraling motion. At this point, recovery actions are required in order to exit the spin. And finally, the recovery phase is the phase where the pilot takes action to recover from the spin. It involves applying proper control inputs, as discussed in our previous video, to stop the rotation and reduce the angle of attack to break the stall. Although we talked about general spin recovery procedure in the first video, to accomplish spin recovery, the pilot should always follow the manufacturer's recommended procedures as noted in the POH, or Pilot's Operating Handbook, for their specific airplane.